Hey, welcome back, students. In this video, I want to go ahead and talk to you about how to balance nuclear reactions. In the previous lessons, you've learned about alpha decay, beta decay, as well as positronic and some of the other emissions. But today I'm going to show you very specifically how to balance a alpha emission or alpha decay example. I'm going to use the one that I've used in the previous lessons. And then I'm going to give you a couple of new ones that you can practice on your own, okay? So let's go ahead and put back that original one that we used for alpha decay in the last couple of videos. And that is the polonium-210. So polonium-210. And it's going to break down into two things. And so we already know what the answer was if you watched that video. But what I'm going to do is I'm going to go ahead and put a blank here because we don't know. I'm going to pretend we don't know. But what we do know is that it's going to release a alpha particle. Okay? And so how do we fill in this part right here that's going to be represented by the box? Something goes in here. Okay? And the way we're going to figure this out is the following way. We know that what goes in here is going to have the isotopic notation that we talked about in the previous video. That means that you're going to have some symbol X, you're going to have an A number at the top, and a Z number at the bottom. And so we're going to have to look at this and try to figure this out. And there is a process. The first process you want to do is you either want to look at the A numbers for all of the atoms represented on the nuclear reaction, or you want to look at all the Z numbers for the atoms in this reaction. Let's begin with the A number. Since it's at the very beginning of the alphabet, we'll start there. So the A number is here, represented by the A. So what we want to do is look at the A number for polonium. Notice polonium has 210. And notice for helium, the A number is 4. So what we're going to do here is we're going to take the following. We're going to take this 210, we're going to take the A, and we're going to take the 4, and we're going to make this into an equation. So we're going to do the following. We're going to say that 210, we'll bring the arrow down, and we're going to convert that to an equal sign. It's going to give us some A number, which is this one here, plus, so we're just going to bring the plus down sign, and then the number at the top, which is the 4. So if you look at this general equation here, we can solve this. Some number plus 4 will give me 210. So if you do the math fairly quickly here, let's go ahead and subtract 4 from both sides. What you wind up getting here is going to be an A number that is equal to 206. So this answer here is what we want to put into the A number at the top. So if we go ahead and do that, we're going to go ahead and erase this portion here. All right? And we're going to replace everything here with a 206. And so let's go ahead and do that, but I'm going to go ahead and break some stuff up that we don't need anymore. So we'll do that. And so what we want to do here is we want to go ahead and scratch this out, and we're going to put 206 in that region there. Now the next thing that we're going to do is we're going to go ahead and turn our attention now to the Z numbers. The Z numbers are at the bottom. If you notice here on this unknown element X, we've got a Z number here represented just by the letter Z. We've also got it for polonium, we've got an 84, and for helium on the other side, we've got a 2. And so what we're going to do is kind of generate an equation for that, and so we'll do that now. So we're going to take the 84, bring it down. That's 84 is equal to some Z number plus, bring down to 2. And so that's going to be 2. So we got to solve for this equation, subtract 2 from both sides. The Z number here winds up being 82. And so what we'll do is we'll go back in here, scratch out the information for Z, and we'll put it 82 in that spot there. So we'll do that now. Come in here, delete this, and then we'll do here, and we'll scratch this out, and this becomes 82. So now what we've got is the following. Let me clean this up. We've got this. We've got 206, 82, and we've got some unknown element X. And we've got to figure out what this is. So the next step at this point is we need to turn our attention to the 82. So what we need to do is go look for this 82 on the periodic table and find out what element we're dealing with. So if we go look at this element 82, we know that when we go up there, and we're going to find out that this element 82, because it is the Z number, in other words, it represents the number of protons, we look for the atomic number of 82, and we find out that the number with 82 belongs to the following. It does not belong to X. In fact, it belongs to lead. So the answer here for this tile that we have up here is that the missing piece here is going to be lead, 206. And notice that I said lead 206 because what I'm referring to is the actual mass, lead with a mass of 206. Okay, so that's one example of how you balance these nuclear reactions. In the next video, I'll show you how to do a little bit more.